Alright, welcome back. I'm going to show you how to do problem number 2. This is Mrs. Nagle, how to solve uniform acceleration motion problems. A rocket leaves a space station on its way to explore Uranus. If it starts from rest, V initial. V initial is 0 and accelerates at a rate of 25 meters per second squared. There's my A. How long will it take to move? So how long, that's my time. So T is question mark. Will it take to move a distance of 20,000 meters? Alright, so I'm going to list my variables, what I know and what I don't know. My V initial is 0. My acceleration is 25 meters per second squared. My distance is 20,000 meters. Now I say, wow, what am I looking for? I'm looking for time. What am I not given? I am not given any information about my final velocity. And if I'm not given that, that means I do not choose. So don't choose any problems or equations. So when I'm looking at equations, any equations that have V final, skip. Because that one's a V final. What's another one that has V final? Skip. Bam. So the equation that I'm going to choose, my bingo equation, is going to be the distance is equal to initial velocity times time plus 1/2 AT squared. So I'll go ahead and write that down. My distance is equal to V initial times time plus 1/2 AT squared. I plug in what I know and what I don't know. D is 20,000 meters is equal to V initial, which is 0, times time, which I'm looking for, plus 1/2 my acceleration, which is 25 meters per second squared, times T squared. Well, what's super duper nice is that this middle term cancels out. So if that middle term cancels out, my life becomes really, really simple. So now I do 20,000 meters is equal to 1/2 25 meters per second squared times time squared, divide through. Now you can, if you want to divide 1/2 right now, what happened to this T squared? Okay, so the question from the audience was, what happens, why did this go to 0? Because 0 times time makes this entire term disappear. So now my middle term is gone, and now I have just this term and this term to look at. So I rewrote them down on the next equation right here, or grouping. Now I'm going to divide by 1/2 25 meters per second squared on both sides. Remember, when you divide by 1/2, you're actually really multiplying by 2, but for consistency's sake, I'll do this. 25 meters per second squared. Now on this side, this cancels with this out, so I'm just left on this side, AT squared. And on this side, I'm getting 20,000 divided by 1/2, which is really multiplying by 2, divided by 25 meters per second squared. I said 20,000. Sure, that's fine. If you wanted to know if I took my 1/2 and multiplied it by the 25 right now, so it's like 12.5, that would be fine. So you can just divide through. And so that multiplication of 20,000 meters divided by 12.5 meters per second squared would be 1,600. Now watch my units. My units were a meter divided by meter per second squared, which is same thing as meter divided by, and then I flip the flag in, seconds squared on top, meters on the bottom. Meters end up canceling. So my unit for 1600 was actually seconds squared. And then this was equal to my t squared. So I'm going to erase my units because I need more room to write. But hopefully you believe me if you work through your math. Now we're almost done, but we haven't solved for the time. So I square root both sides. Notice when I square root my time, my unit was squared inside the square root, so I can square root both numbers. So my s squared becomes a single s, seconds, and my number becomes 40. So now I have 40 seconds, and my t squared now becomes a single t. It takes me 40 seconds to go a distance of 20,000 meters. And that's the end.